Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
Welcome to another episode of the Distributed Data Show. I'm David Gilardi, a technical evangelist, and I'm here today with Jeremy Hanna, a Vanguard solution engineer, and Jim Hatcher, who is a senior solutions architect. And we're going to dig into some fraud use cases with graphs. So, hey guys, how you doing? Jeremy, and then Jim. There we go. That's, I could have told you. Here, to our audience, I could have actually given them instructions maybe to respond or say something there, but that was my bad. So anyway, and yeah, so you guys are here in front of me remote. So we got Jeremy and we've got Jim. And all right, so with that, why don't we go ahead and do this? Let's, I'll admit, guys, I am a layperson when it comes to, working with like fraud detection and these particular use cases. So I want you guys to help me, which is going to help everybody else understand, what kind of use cases, like what does this landscape look like?
I think, fraud use cases in general have a lot of commonalities, whether it's insurance fraud or payments fraud or credit fraud, and in the sense that there's some seminal moment, there's some decision point where we're trying to decide, is this good or is this bad? And so they usually involve some similar technologies in order to solve that. There's usually some domain, some object space around that case, whether it's you're a customer placing an order or you're a person making an insurance claim, so there's some kind of calculation that goes on to say, hey, we got a decision to make here. Does this thing look good or does this thing look bad? And there's some knowledge that the business has about, hey, we know what a good transaction looks like, and does this look like a good transaction, or does this have some deviation from that normal thing? And so it's an interesting problem to solve. There's usually some time sensitivity where we need to get a quick answer, but we also need a very accurate answer because there's a lot on the line in terms of business value, profit or loss.
So if we take an example, like an example, I'm just going to take one like personally, right? So I have my credit card, I have my debit card, things like that. And this is just, I'm assuming one case, right? And I have some relationship with some bank or some entity for that card. And they are going to be, nowadays it's pretty normal, right? That there's fraud protection with that. So right now I happen to be in San Francisco, I live in Orlando, maybe all of a sudden I make some purchases and they're like, hey, wait a minute, you don't live here. Or, maybe they look at some of that historical data and I'm sure at some degree they'll know that I travel here a lot, but they see a weird purchase in Texas and all of a sudden it flags something. So is this, that's the kind of stuff you're referring to there, at least that one case?
Yeah, absolutely. That same thing happened to me the other day. My daughter was buying a MacBook, and so we got online and we're ordering the MacBook, and it got flagged by my bank and as potential fraud, and I had to call the bank and say, no, that's really me making that purchase. And the reason for that is because a MacBook's it's very easy to convert into cash. Somebody can go steal your credit card and go place an order for a MacBook, and they, if that goes through, they get that MacBook, they take it down to the pawn shop, and that's just like taking money out of your pocket. But that's a great example of somebody understanding that domain. That my bank said, if you're making a purchase from Apple, that's a higher risk transaction than if you're making a purchase from Domino's Pizza. You're probably not take that $20 pizza and turn it into cash. They know that because they've studied the statistics around their transactions, and so they've got models in place that are making those decisions for them in real time.
And that brings up an interesting point too, I think, is like you mentioned earlier, the different types of claims, for instance, and an insurance claim is obviously going to have a different SLA because there's like mail involved and faxing and that sort of thing, rather than a point of sale with somebody with a credit card or online transaction. Those require very fast. But then also the use of models versus other data, so geographies or how long your account's been open, or a threshold of amount of money that a certain transaction is using, and then maybe, like you said, if you're buying something from Apple versus buying something from Amazon or something like that, they might have a slightly different characteristic to it. And so I think all of those things are taken into account in some form to produce a real-time decision. And then I think one thing that we don't see sometimes is behind the scenes, if something is flagged, or if something that you might see a postmortem of different transactions behind the scenes, and they want to be able to visualize certain things of, was this really fraud? Or do we need to flag something for review because it's an inconvenience for our customers? The security versus convenience question of, we want to allow as many transactions that are valid through as possible and be aggressive, but not overly aggressive to the point of having false positives.
Yeah, I could see that, especially if you have if it's too overly aggressive, right, and you're constantly declining every transaction that comes through. That might get a little annoying, even though you're trying to ensure that you're not going to have any fraud cases. So it feels like there's a balance there, right? There's got to be, as you just mentioned, security compared to convenience. That there is a balance that needs to be achieved.
Yeah, and I think part of that spectrum is the business value that the business is going to get out of it. In other words, if you're that insurance company Jeremy's talking about, and you pay out some claims that are fraudulent, you overpay, $1 million worth of claims or something, that has a significant impact to your bottom line.
Yeah.
If you're Apple iTunes and you're doing every transaction's a 99-cent thing, it's a very different picture in terms of business value. But or you might be doing so many 99-cent transactions that the volume of it changes the dollar value. So
and the characteristics certainly change. So talking to some insurance companies, they have situations where a doctor hasn't been practicing for the last couple of years, and yet that person is writing 100 prescriptions a day for something that it is expensive. And so that could be a suspicious transaction. And you don't have that kind of data with a 99-cent iTunes transaction. And so the amount of data, what's normal, what's not normal, and how big of a picture you have. But I think, and tell me if this is going a little too far ahead, I think the more information that you can use in order to avert or get the valid fraud cases faster. So you might have incoming messages from different authorities about common patterns that they're seeing, and you need to react. But then also, Jim, you were telling me the other day that there was something with relationships that you, in your experience in the fraud detection industry and the transaction processing, there was something that you were just unable to do previously.
Yeah, if you're talking about like real-time decisions, you think about, going on to Amazon or something, and I'm trying to buy this book, and, I hit submit the order, and, Amazon has to decide, very quickly, is this a fraudulent order or not? Or, any type of e-commerce type of transaction like that, you have the information available to you about that transaction, who the customer is, what the payment method is, what product they're making a decision, that they're trying to buy. So you have that immediate, the details of that transaction, and you're often taking that and you're digging into your database. What else do I know about this customer? What else do I know about this product? What else do I know about this payment method? And trying to put some additional context around that. And it's often a kind of a balancing act between I gotta make a quick decision, but I want to do as much digging as I can. So, a lot of times if you can kind of peel that onion back one layer, you get some picture of it. But, my experience is, if you had time to sit down and 30 minutes to go through this transaction, if you could dig into it, peel back several layers, all of a sudden you start getting a lot more, context about what's going on. If you can say, hey, this customer used the same credit card as this other customer, and that customer is logged in as the same device as these other 20 accounts. Why would somebody log on from 20 different accounts? And then so sometimes when you can go a couple layers deep, things start popping to the surface that you think, ooh, something's not right here. This is not a normal scenario.
Yeah, and I think the tooling and the kind of the way that we typically store things is in a very flat form. And so I think fraudsters kind of take advantage of that.
Fraudsters? What are What are fraudsters? Are they the good guys, bad guys? What are they? What is?
So people who try to execute some sort of fraudulent transaction.
Okay, so they're not related to speedsters.
No.
No, they're fraudsters where they wear black hats. And they live in the dark web in some nefarious.
So
sorry, Jeremy. Go ahead.
They're going to exploit whatever they can, and so if they have like mule accounts or some other levels of indirection that allows them to kind of stay in the shadows and not be found out because a company doesn't know what they don't know, and if the tools that they have primarily are associated with that flat data, that single transaction, then they're not going to take a step back and see a bigger picture of what else is at play. It reminds me actually of fraud in terms of I heard a story about, and it's a true story, about human trafficking, where somebody came to an airport, and as they were presenting themselves to a country to enter a country, they did some investigation. Something seemed kind of off, and they did some investigation, kind of like some PI type of investigation. It turns out that that person was a human trafficker. Somebody else on that same flight, through some relationship-oriented kind of peeling it back a few levels, was also a human trafficker. And they had two people that were, being trafficked at that moment. And when we had a conversation with them, and it in terms of fraud, I mean, this is a very kind of egregious form of fraud. If you could operationalize that level of investigation into something that was automatic, then you could save lives in that case.
Wow, that's okay. That's pretty profound. Yeah.
I think fraud can be a bigger picture than monetary, but I think the results are the same. Finding those who want to do bad things in various surface levels, and I think what we're talking around this is that sometimes you have to go a couple of hops out, a couple of neighborhoods out, if you're thinking about it in terms of, if you store your data in a way that can be traversed from one point to another, you can start to see relationships being valuable in terms of detecting more types of attacks in the sense of fraud.
So I want to dig into that a little bit. And I also want to summarize things from what I'm hearing from you guys. So it sounds like, okay, there are multiple different use cases for fraud overall, obviously, right? We've got the monetary ones we were talking about. We've got like a human trafficking. I think there are different ways that you can kind of look at the types of actions that people are performing and kind of categorize those as fraud. And then you've got detecting the actual people performing the fraud, right? There's this piece here. Now, it feels like with all of those that there's got to be, I would think there's got to be a difference between when you are, say, processing data in a more near real-time or real-time fashion compared to when you're looking at historical or analytical data and how that's handled, and the kind of technology that's used for that. So I'm curious about like what were we doing before, and has there been a change, like from a tech standpoint? Like so there's actually a couple questions. I'm totally throwing a couple questions all you guys at the same time, right? You have one from the real time to like analytical batch part, like what are some of the differences there? What do we see there? And then from a technology standpoint, like historically, right? Was there a way that it was being done or is done today, and are we seeing any change to any newer types of technologies or anything that's like, increasing the game, kind of making our ability to do fraud detection that much better?
Yeah, I'll take a crack at that one. I think historically you've seen the use of rules engines and like business. I can think of the acronym, but systems like these workflow systems that say, tell me what you know about this transaction. I'm going to filter it through a set of rules, and those rules are either going to tell me, hey, this is good or this is bad. And then there's some group who's analyzing what's going on, and they say, oh, hey, we're missing this fraud over here, so let's create some new rules. And so it's a very kind of manual, human type of a thing, but responsive in the sense that if somebody says, hey, I see a fraud pattern going on, I'm going to put a rule in, and within an hour or so, I can get that deployed into our production decision process, and it can start shutting that down. But that involves a human detecting what's going on, and a human trying to define a rule. What does that? And so I think a big shift over the last 10 years is the use of machine learning, data science, advanced statistics, and where people say, hey, let's look at our historical transactions now that enough time has passed where we know whether or not these transactions actually were fraud, or if they weren't fraud. We can label them. We can go offline with that data. Go through a process of writing machine learning algorithms against that. Creating some training data, creating some validation data sets, and we can build something like a logistic regression model or a support vector machine, something that knows how to take labeled data and create a probability from it. And so the use of those, and then we can take those models and we can use those in our decisioning process. And so the use of those models, I think, is becoming more of the norm, or you see situations where people are using their rules engine, which allows that human touch in concert with these machine learning algorithms. But in some cases, it's moving more towards the machine learning algorithms where they're kind of running the show, or you see the same type of thing where people are using machine learning to say, how should we segment our data? Should we think about these types of transactions in one way, but these types of transactions in a different way? Should we say, hey, all high dollar electronics volumes are going to go through this model because it has a different set of interesting factors for fraud, where Domino's pizza orders are going to go through this kind of a fraud model. So there's some interesting things you can do just about thinking about how you want to segment your data to even apply models. So I think that whole statistical learning, the machine learning, is really kind of, it pervades the space now. And if you've got a way to get some additional insight out of your data, and you can pull that into those models, that's a competitive advantage for you in terms of your business, and so I think that's a big thing I see. And so the use of graph databases, I think, has an interesting role there.
Yeah, I was just about to ask you, actually, is there are we seeing then a tie-in, right, to the capabilities you get with graph?
Yeah, I think that can be used in a couple places. One, it could be used on this analytical side, the batch side, because you can use algorithms and graph to look at centrality, to do segmentation around your data. So you can use it on that batch end, or you can use it on the real-time end. So if you create a model that's going to make decisions about your transactions, you make these fraud decisions. Those models have inputs, and so the model might get built and say, hey, I need to know, as part of my decision process, how many times has this customer used this credit card in the last 30 days? And so you have to calculate that in real time to feed that into the model. But the more complex that your algorithm is, if it says, hey, I need to look 6 levels deep to create some of those inputs, then graph can be used on the front end to say, hey, given this credit card, go query the graph in real time, calculate some of the things that the model needs, and then fill that in. And so you can use graph on the front end for that real time case as well. We talk about graph databases have a lot of value around when the relationships between your data are valuable. Then graph databases are often an interesting solution to look at, and that's certainly the case in fraud. So that's what I would say about that.
Yeah, so are we seeing, I would make an assumption then from a graph database standpoint that because of that focus on the relationships, right, of data, and that graph databases are really good for representing those relationships. I'm going to make a base assumption that there is, from what you just explained, right, that there is a movement are we seeing more and more folks actually using graph databases for these types of capabilities compared to the straight up rules engines and such, or is that a trend?
Sure. So I think there's been more interest. I think that people are finding that some types of organizations, depending on the type of transactions they see, they can rely less on the geolocation and rely less on the rules and more on the models. And they've been looking at, ways of differentiating, and that's kind of an odd word for that, but ways of getting ahead of it, because fraudsters are getting more and more sophisticated in how they're approaching things. And so I think it gives them another tool set in order to be able to detect some of these things. So yes, we have seen, as a company, we've seen that we have DataStax Enterprise Graph, which is a scalable graph that can ingest a ton of data, like a lot of metadata, contextual data, transaction data, and be able to do these traversals in real time. So yeah, I think that it's becoming more of a trend that can be useful in the detection of fraud.
I think it's interesting to note that a lot of the fraudsters are pretty tech savvy, and just like these like financial institutions are monitoring the type of fraud that's going on in their processes, the fraudsters are monitoring what's working for them. So it's like this cat and mouse game where the fraudsters change something, and then the financial institutions react, and then the fraudsters react, and so like in fraud. In anti-fraud, the anti-fraudsters, the good guys with the white hats, they have to rely a lot on lots of layers in their solution. You can't just say, hey, this one way of looking at the data that's gonna find all the fraud, because as soon as you start to rely on that, then the fraudsters adjust, and so anytime you have different data points and you have different ways of kind of drilling in. That's an advantage, and a lot of organizations, it's not just a binary decision, and that this is fraud or this is not fraud. They'll say, okay, this is clearly fraud, this is clearly not fraud, but there's this gray area in the middle. And for orders or for transactions that happen, like we're talking, payments fraud, e-commerce type of transactions. Hey, we're not sure if this is fraud or not. Let's have a human look at it, and a lot of organizations are using visualization and that type of a setting to say, okay, let me look at this transaction, and being able to use like graph visualization to look at it, you can say, hey, let's take a look at this customer, and then let's look at everything that's going on that we know about that customer, and then you start to expand that. They might look at that and say, oh, this is definitely fraud. Now that I can see that. And then they can use that as a feedback loop to say, okay, can you describe to me why that looked like fraud to you? And you can say, yeah, well, because of this little thing here going on. And in fact, I could write a rule, or we could summarize that in such a way where we could feed it back into the model where this won't go to order review anymore. This will fall into that definitely deny category. So you get that feedback loop.
And I'd take that a step further too, is to say you not only can detect it in post-review, like a post-mortem type of situation or exploration of the data, but you can also test that hypothesis over the historical data, because you have the validation or test set of things that are fraud, and there's the uncertainty of, well, maybe we haven't detected it before, but there's at least some way to test your hypothesis to see that if you could have false positives or false, how reliable is that going to be, or how noisy is that going to be for customers?
Yeah, so that's really interesting. So it sounds like, from what I'm hearing, right, is, yes, even though there are newer technologies like graph databases, right? Well, technically not new, but I'll put that aside for a moment. But more emerging and popular technologies like distributed graph databases that are, it sounds like, enhancing the capabilities, right, that we have overall for providing fraud detection. I'm hearing, though, that there are still humans in the loop. This isn't just totally back end machine learning, rules engines and stuff all in the back end, all doing this. That there are humans in the loop that provide. It sounds like a place where maybe things that we can't quite detect with some of those capabilities, that they come into play and they can actually feed that data back in. Like the example you were giving, Jim, where you're talking about someone who they can see through the visualization that actually, no, wait, there's something going on here. Let's feed that back into the system, right? So there's still this interplay, right, between the machine and the human part of it, and you kind of need both still, even with the newer technologies.
Yeah, I mean, obviously having like a call center staffed with people to take to be looking at orders, things like that. That's expensive for some cases, for some businesses, but depending on the value of approving a transaction that might not have gotten approved, it may be well worth the cost. Or for some organizations, they might have a situation where they say, hey, I've already got a call center staffed taking support calls, and that those same folks, when they're not actively taking a call, can do order review. So I don't have to add additional staff necessarily, or but they're often looking for ways to say, hey, let's take the feedback that we get from those manually staffed, those human touch points, and let's try to use that to better the models, to better the other things. Like, obviously, businesses want to automate those kind of things as much as possible to make their solutions scale well.
Okay. No, that makes a lot of sense. So, as we getting close to wrap up the conversation a little bit here, I just want to kind of open it up for you guys. Are there any other things as far as this particular topic that we're on? Any other items that you guys want another use case or anything that you think is important that we should talk about before we close out? Totally putting you on the spot. It's my fun. I get to put you on the spot.
I guess I think it's sort of interesting. We talk about what use cases are good for Graph, and sometimes we talk about personalization, or we talk about customer 360, where we just want to understand everything there is to know about a customer. To me, Graph is like the perfect use case, fraud is the perfect use case for Graph, because you're often looking at somebody that I don't know anything about, and can I look at the data and the data surrounding them, and look at the neighborhood of connected things, and try to get a picture of who they are. Like with the customer 360 case, that's my customer, my known customer. They've given me their information and I know all about them. This is somebody who's trying to transact with me, and I think I know things about them, but I'm using Graph to find out the things that maybe I don't know about them. So it's very alluring to me. I think it's an exciting area to work in, because like what Jeremy has mentioned, that you can use this for things like human trafficking, where by making the right decision, by doing this investigative work, pulling out the details of this transaction, you're making significant impact on the world. But even in a relatively boring situation like payments fraud, I mean, the folks, these fraudsters we're talking about, they're criminal groups that are acting around the world. In that case, even that kind of a thing, you're just using tools to make the best decisions possible, to stop people from breaking the law. To me, the anti-fraud thing is just it's a fun space to work in. It's a meaningful place to work, and I think Graph and tools like this may just kind of make you that much better at it. It's fun to me.
Yeah, to that, I already get into Graph. I love it. I think it's a lot of fun. It's a really cool tech, the capabilities with it, especially coming from years with the relational world, where when you're trying, the idea of being able to traverse the amount of, connected entities, like between vertices and stuff that you can do in Graph natively, and trying to do that kind of same thing in a relational world, it opens up a whole new thing. But like, as you're talking about that, like, I already get excited about this stuff, and you just got me more excited. Because I was like, that's cool. It's like, no. And honestly, that's a really neat. I think that's a really neat example of a way that this kind of technology can kind of really help in the whole fraud use case scenario, and as you put it, the world. Right. End on that right there, on the world. All right, guys. Well, hey. Thank you so much, Jim and Jeremy. This has been awesome. And thank you everybody for watching another episode of the Distributed Data Show. See ya.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel, or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.